Alrighty, let's go ahead and talk about shapes. This is symmetry. Remember, we dealt with translations, reflections. The last one is symmetry. Symmetry meaning evenly. That's why I think of it as, sorry, this message. Example one, first we have the line of symmetry. That means it cuts it evenly, like half. So I wouldn't say half, because half means like, one part and another part. I would say it cuts it evenly at equal parts. Here we have lines of symmetry, so it divides evenly. For polygons, that means for regular polygons, that means it divides it evenly. So let's say for a triangle, it divides it evenly by the number of sides. So it has 3 sides, so it divides it evenly by 3 lines of symmetry. Let's say a regular pentagon. Pentagon has 5 sides, so therefore it cuts it evenly, 5 lines because there are 5 sides. Example 1. Here it says they want us to draw a line of symmetry, so we can go ahead and see if it's even or not. In this case, if we were to draw a line down the middle of the heart, we were to break the heart, we have this. Oh, can you see it from the glare? Yeah. Okay. So here, if you can see it somewhat, a big head showing right there. It cuts it evenly in half, so yes, it's symmetrical. Here, if I were to cut it this way, it doesn't work. Let's say if I cut it the other way, so this way. It also does not work because it's slanted here. If you were to fold it in half, it wouldn't be symmetrical at all. So in this case, it's no. Here we have rotational symmetry, meaning to find that, they want number of degrees. It's 360 divided by n. N is considered the number of times it can be rotated symmetrically. Some of these shapes, if you rotate them, like if you cut them down the middle, they're not perfectly symmetrical, but if you rotate it, they can be perfectly symmetrical. In this case, n is considered your order of rotational symmetry. So if we look here, I have the drawings here on my paper. I did the best I can for the n's. I just got lazy on the board. So if I were to flip the n 90 degrees, so I flipped it, I moved it this direction. So when I moved it this direction, I end up with that. This does not look like that at all. Let's say if I have it, it's sideways now, and I move it up, it looks like this. And if you notice, this and this looks exactly symmetrical. They look exactly the same. And let's say I have from upside down, and I flip it another time going this way again. So I'm flipping it 360, so I can't really move that with my hand. But when you do that, you end up with that, and it looks exactly like that. So for this one, I actually flipped the paper around, and it actually looked very symmetrical. So here, they have 2 sets that are very symmetrical, meaning to find your order of symmetry, we only have 2 pairs. So our order is equal to 2. And for degrees, you do 360 divided by the number which you have here, divided by 2, and you end up with 180 degrees. So that's the rotational symmetry. Next one you have here is a box with a diamond in between. If we were to rotate it one way, we would have the exact same shape. Let's rotate again. We'll have the exact same shape. And you rotate it again. No matter how many ways you rotate it, so it's up to 360. So you grab the shape. It's just like this. This is one way. This is 90. This is 270, and this is 360. Sorry, 90, 180, 270, and 360. So that means we're going rotating in degrees of 9. But in this case here, if you do it, if you rotate it all around, you end up with 4, order of 4. Also because the number of sides there, you can only rotate it 4 times. You can't go backwards. It means the same thing. So the order is 4. You do 360 divided by 4, and that's how you get 90 degrees. So your rotational symmetry is 90 degrees with an order of 4. Your last one, I drew it out. So let's say we moved it 90 degrees. I moved it upward. It looked like that. I flipped it again. It looks like this. If you notice this and this, I always determine by the lumps. Be careful how you draw this. I drew it perfectly in my paper, but if you notice here, it does not work. And then I flipped it again another time. So for these two, if you notice the lumps, this one goes inward and this one goes outward. So these two do not work as well. But my beautiful drawing right here, you get to see it. They don't work at all. So these do not work. This one does not have anything, doesn't have any order, does not have any rotational symmetry. Now looking back at example 2, they want you to draw this original shape here. I have that there. They want you to draw it in terms of 180 degrees, so you want to rotate it. So for rotating, I'm grabbing this shape and I'm rotating at 90 degrees. So now this bottom part here rotates here to 90 degrees. So this part moves up here, this part moves up here. That means this triangle goes from here to here. And if I were to draw that would be 90 degrees. And then from the 90, I'm going to rotate it again because they want 180. You can't just magically draw 180. I think you have to go 90 degrees at a time. So, you know, left, right, up and down, etc. So now, from this point here, I have to rotate it yet again. So when I grab this triangle, I always focus on the end here. So if I rotate this again, this will have an end right here. And then everything's followed. So this goes up here, and this will be down here, and you have 180 degrees, and that's how they have that rotational thing. I wish I could show you a better picture of how it rotates, but you're just grabbing that shape and you're moving it 180 degrees. That means you're moving it twice. And that's it for the lesson. So just make sure you're going in order, see how many times it can focus, it can move around. I love you guys. Take care.